Hello and welcome to Math Physics Engage. In this video, we will be looking into real-world applications of rectangular coordinate systems and graphs. So let's get started. Here we are given a problem that a small craft in Lake Ontario that sends out a distress signal, and based on that, we have two boats that are close to it, and we need to figure out of both of these boats which one will reach the boat in trouble the fastest. So that is the problem, and we are provided with the coordinates of each one of the boats. Now here it is mentioned that both rescue craft travels at the same rate. So in this way, the speed is not the issue. The main thing that we need to figure out is the distance between these boats. The boat that have the smallest distance between them will reach there fastest. Okay, so once we have defined that, let's plug these values of the coordinates on our graph here. So in order to plug in the values, first of all, we need to identify our axis here. So I have the horizontals. Let's it write as my x-axis, and the vertical is the y-axis here. And where these two lines meet is our origin, present here having the coordinates of 0 and 0. So we measure everything from a reference point that is the origin. So first of all, let's figure out where the boat in trouble is present on the graph. We are looking for the value 49 along the x-axis. So let's count. This is 10, 20, 30, 40, and 50. So along the x-axis, we are present here. And then on the y-axis, I have 64. So this will become 10, 20, 30, 40, 50, 60, and 64. So let's identify the point. Okay, so I have my point, that is the boat in distress, having coordinates of 49 and 64. Now the two boats that are the rescue boats, one of the coordinates is 60, 84. So let's figure that thing out as well. I have my 60 here, and then 82, that is 70, 80, and 82. So we are 60 and 82. And finally, the second Coast Guard craft having coordinates of 58 and 47. So 58 is this point, and 47, and I have it as here. Okay, so these are the three points on the graph identifying the location of the boats. Now we are looking for the distance between these. Let's say here I give it a variable d1, that is the first one, and for second one give it d2, that is the distance between the second boat and the small craft that is in trouble. Now all we need to figure out is the distance d1 and d2. Whichever one is the smallest will reach there fastest. Now we can use the graphic method using the rulers and measure the length of each one of these lines, or we can also use our distance formula to solve this thing. So let's use the distance formula. d1 is equals to the square root x2 minus x1. These are the x coordinates I have. Square y2 minus y1. These are the y coordinates between the 2 points. So x2 is given as x60 minus 49, and y2 is 82 minus 64. Okay, now simplifying this, it will become 11 square plus 18 square. And if you simplify this, it is coming around 21.1. Okay, similarly, we can do the distance d2 here. So d2 is again using the same formula of x2 minus x1. In this case, I have x2 value is 58 minus 49 square plus 47 minus 64 square. Simplifying, this is equals to 9 square plus minus 17 square. And if you simplify that, it is coming around 19.2. So the distance between boat 2 and our boat in distress is the smallest one, so that one will reach there fastest. I hope you like the utilization of distance formula in some practical applications.